Today we are talking about sums of infinite geometric series. So two things I want to talk about. What does infinite mean? Goes on forever. Number two is, what is the difference between a series and a sequence? Series is when you add them up. Sequence is just the list of numbers. Okay. Now, infinite goes on forever, which means most of the time you would think if it's going on forever, there's no way you can find the sum. But if your ratio is in between -1 and +1, you can find the sum because it's going to get closer and closer to a specific number. Okay? So what numbers are in between -1 and +1?
0.
Okay, 0, but what other numbers?
1, 5, 6.
Fractions. Okay? So basically what this is saying is if your ratio is a fraction, positive or negative fraction, you can find the sum. Remember when we are doing our exponential graphs and we had like our graphs that went kind of like this and your number got closer and closer to 0 but never got to 0? That's like what's happening in here. Our answer is going to get closer and closer to a number, and if you could add forever, you would get to that number. Okay? So it's saying that this sum will end up equaling this number if you could add it forever. Okay? So just get closer and closer to that number. Okay, but your ratio has to be a fraction. Okay, so in order to find this formula and find the answer for an infinite series, you need to know your ratio. Do you guys remember yesterday on how I told you how to find your ratio? Well, it's what's multiplying between the two terms, but if you didn't know, like if it's kind of, sometimes they're weird numbers, which are fractions. You divide them. You always take the second term divided by the first term. So if I take 2 divided by 1, my ratio is what? 2. Okay? And that will work for all the numbers in this series. If I take 16 divided by 8, what is it? 2. So do you see it doesn't matter which two numbers you pick, as long as you do the second one divided by the first one, you will end up with a ratio of 2. So could I find the answer to that one?
Yes.
No, because it's not in between -1 and 1. Okay? Now let's go to this infinite geometric series. I have 1/2 divided by 1, which is a half. Could I find the answer to this one?
Yes.
Yes, I could, because it's in between -1 and +1. Okay, so this one would be no sum. You could have no solution on this one, or this one I could find the sum. So I'm just going to put could find the sum. Okay. Now, what is really nice about infinite geometric series is that if your ratio is bigger than 1, okay, or less than -1, you can't find the sum. Therefore, your answer is no solution and you're done. Okay? So that's pretty easy, right? Then, if your ratio is in between -1 and 1 and you can find the sum, this is your formula, which is also a pretty easy formula. Okay? So today I feel like is one of the easier lessons. Okay. Example 1. Find the sum of each infinite geometric series if it exists. And the reason why they say if it exists is if your ratio is too big, then the answer would be no solution.
Yeah.
Good. Okay, so the thing you always have to do first is to find your ratio. So how will I find my ratio in example 1? Good. 4 divided by 8, which reduces to what?
2. Or, no, 1/2.
1/2. Very good. Okay, so my ratio is 1/2. Can I find my infinite geometric series sum?
Yes.
Yes. So that equation was sum equals A1 divided by 1 minus R. So my value for A sub 1 is what?
8.
8 divided by 1 minus, and what is my R value?
1/2.
1/2. Very good. Okay, so now when you're subtracting fractions, you always need to get what? Common denominator, right? The denominator right now is what? 2. So my common denominator is going to be 2. So all that happens with this 1 is I'm going to change it to be 2 over 2 minus 1/2. If this fraction had been 1/3, I would have changed this to 3 over 3. If it was 5, I would change it to 5 over 5. Okay? So whatever this denominator is, you're changing that one to those values. Okay, so when I simplify this now, I have 8 over what? 1/2. And how do I get rid of a fraction over a fraction? Good. You multiply by the reciprocal, which is 2 over 1. So both the top and the bottom. These cancel. Can I write 8 as a fraction if I wanted to? Yeah, you could put it over 1. But there's nothing, there's just ones on the bottom. So we multiply that and we get 16 is my answer. So that means my sum is approaching 16.
So it's kind of like double the second number.
Not always.
Not always.
Sometimes. Okay. Questions before I move on? Okay, then I'm going to move on. Yes? All right. Okay. So remember on these problems, the first thing you're always going to do is find the ratio. So I'm going to give you about a minute to see what you think with example 2. And once you get your answer, if you circle it on your papers, you can kind of show me. Good. Pencil or pen? Okay, so how do we find our ratio? How do we find the ratio?
Divide.
Divide, right? So what two numbers did you divide? Good. So if you take -3 divided by -3 divided by 1, what do you get? -3. Is that in between -1 and 1? No. So you're done. Sum does not exist. Okay? If it doesn't end up becoming a fraction that is less than 1 or greater than, yeah, I don't know what I'm saying. You guys know what I'm trying to say?
That no matter what.
Yes.
Okay.
Okay. All right, moving on. Find the sums of each of these infinite geometric series, if it exists. So our equation, remember, for when you're finding a number in a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. So in order to find the sum, remember that our ratio has to be in between -1 and +1. Okay, so can I find the sum of this one? Yes. And if you notice on this one, I don't see the a sub 1 term, which means that really it is 1 in front. Okay, look at B. Is there a sum for B? Why is it no? Because this is greater than 1. Okay, so even though it's a fraction, this fraction is bigger than 1. So be careful. So this one, we're actually done with B. We're just going to write no solution. We can't find the sum for that one. Okay, so back to this one. Our formula, remember, for finding the sum for an infinite geometric series is a sub 1 divided by 1 minus r. Okay, the way they have this set up, do I know what my r is?
Yeah.
What is my r? -1/2. What was my a sub 1 value? 1. So let's plug in our information. We have 1 over 1 minus -1/2. And make sure you are always careful with those double negatives. Okay, what happens when I have a double negative? Very good. And then what will I do in order to combine these terms? Common denominator. What will be my common denominator?
2 over 2.
Good. So 2 over 2 plus 1/2 makes what? 3 over 2. Right? 2 plus 1 is 3 because this is adding. So that means I have 1 over 3 over 2. And then how do I get rid of the fraction over the fraction? So I multiply by 2/3 to both the top and the bottom. These all cancel. And 1 times 2/3 is 2/3. So my sum is 2/3. Okay. C. This one, they don't tell us what our ratio is. How can I find what my ratio is? Very good. We take 3/4 and we divide it by 3. And I might want to make 3 a fraction. How do I make 3 a fraction? 3/1. And then I multiply by the reciprocal. So I have 1/3 to both the top and the bottom. And what happens? So what's my ratio? 1/4 is correct. Okay, so I'm going to give you about 30 seconds to find the sum on your own. When you get the answer, you should be able to show me on your fingers what the answer is. Oh my goodness, how are you going to learn anything? Okay, here we go. What is A1? 3. Divided by 1 minus R is 1 minus 1/4. What will I change 1 to? Very good. So 4/4 minus 1/4, minus 1/4 equals 3/4. So that means I have 3 divided by 3/4. How do I get rid of that fraction? Multiply by the reciprocal, 4/3. So I do that to the top and the bottom. These all cancel. I'm going to change 3 to be 3/1. 3's cancel. 4/1 just equals 4. Any questions? All right. Example 4. Write the repeating decimal as a fraction in lowest terms. I'm just going to tell you a shortcut.
Sounds good.
Sound good? Okay. Where do you notice what place does this one start repeating at? Okay, so it goes 6, 4, 6, 4, 6, 4. What place is that? Hundredths, because it goes tenths, hundredths, thousands, and so on, correct? So you write this as 64 divided by, it's in the hundredths place, so we're going to go 100, but you're going to subtract 1. So that means I actually have 64 over 99. If you take your calculator, and it's always a great idea to double check these if you have a calculator and can use it. So I have my calculator, 64 divided by 99 equals, and oops, there it is. That was kind of funny. All right. Yeah? Okay, so B. What place does that start repeating at?
Oh, the first one.
Yes, the tenths place. So we're going to write that as 3/10 minus 1, which is 3/9, and 3/9 reduces to 1/3, and hopefully that's a decimal you guys know, but if not, you can always double check it in your calculator. 1 divided by 3 equals... Yes.